All right, so in example 3, we've got this derivative right here. So this is our differential equation because the equation is the derivative. But you'll notice this one controls x and y, right? So your points, your slopes are going to vary based on a lot of different things. So this is when it starts to get a little bit more complicated, okay? So my derivative is controlled by the opposite of x over y. Okay, so for the point 3, -3, I'm going to have -3 over -3, which is 1. Okay, so my slope at the point 3, -3 is going to be 1. All right, my slope at the point 3, -2, well, the x is -3, the y is -2, so this one's 3/2. Okay, my x is -3, my y is -1, so this has a slope of 3. Okay, my x is -3, my y is 0, so this one is undefined, so this one goes to infinity. Okay, x is still -3, y is 1, so this has a slope of -3. Okay, my x is still -3, my y this time is 2, so this is -3/2. -3 over 3 is -1. So this one looks like it's kind of symmetric this way, where we go from infinity, 3, 3/2, 1, and this way is the same thing, it's just the negative of it. So hopefully that pattern holds up so that we can kind of make this a little easier on ourselves. So let's see, here we go. So if this is -2 over -3, this one's 2/3. Okay, this is -2 over -2, which is 1. -2 over -1, which is 2. -2 over 0 is infinity. Well, look, all the zeros are going to be infinity because they're going to have 0 in the denominator. So I'm going to go ahead and fill the rest of those in because I already see that that's going to happen, right? So save yourself some work. Once you catch on to what's going on, just plug those in. All right, so if we plug this in, so -2 back to our 2's, -2 over 1 is -2. -2 over 2 is -1. And -2 over 3 is -2/3. Okay, so my pattern's holding up, where if I figure out this side's just the negative of them. Okay, so that's going to work out really nicely to my advantage. So if I plug in 1, that's -1 over -3, that's 1/3. Okay, if I plug in 1, that's -1 over -2, that's 1/2. -1 over -1 is 1. So my pattern should hold, and I should get the same numbers, but the opposite sign. Easy enough. If I plug in 0 on the top, I'm going to get 0 over whatever. Well, if I plug in 0 on the top, I'm going to get infinity I'm going to get 0, the whole time, right? Because 0 on the top of a fraction gives you 0. So I'm going to go ahead and fill those in too. That was way easier. Okay, so here we go. Let's go again. -1 on the top is 1 over -3. 1 over -3 is -1/3. Okay, well, that's almost the same as this row. Well, let's see. Let's keep going. So -1, so that's 1 over -2 is -1/2. Okay, I'm sensing a pattern here again. 1 over -1 is -1. These are the opposite. So now we're into the fact that it's the same. Now the sign's just changing. So we can check that and we can plug them all in, but for the sake of time, I'm going to go ahead and just do this because it's going to end up being the same. And then these change signs back, right? And then the same thing would happen here. If I plug in -3, that's 3 over -3 is -1. Well, that's the same thing I'm starting to have up here. So it should end up the same. Now on the AP test, I would make sure I plugged most of them in, right? But they're not going to give you 900 million like they're giving you right here in this example. They're just going to give you like 8. So it's not going to be that hard to plug them all in. Okay, so I would do that. Okay, so let's take a look at what the slope's going on here. So all of my y equals 0s. So all of the y equals 0. So all of these points are infinity. So all of these guys should be straight up and down because these are the y equals 0s. Okay, all of these guys are my x equals 0s. So x equals 0 is right here. So these are all horizontal. This is already turning out kind of interesting. Okay, so let's look at here. So 3, -3. So let's start with our same point. 3, -3. It's got a slope of 1. okay? 2, -2 also has a slope of 1. So all of these points, 1, -1, also has a slope of 1. So all of the points on this diagonal, except for this one, are all at 1. So I'm going to go ahead and do those to save myself some time. Is that okay? Okay, let's look at this next point. 2, -3, so 2, -3 has a slope of 3 over 2. So that's up 3 over 2. So that would be like here-ish. So that would go up 3 over 2 to like here. So that's going to go like this. Right? It's going to go like that. Okay, so this one's got a slope of 1. This one's going to be slightly steeper than that. Okay, slightly steeper than that because it's 1.5. Okay, so let's keep going. So 3 over 2, there's not really a pattern that falls with that diagonal, so we'll move on. 3, -1. Oh, that's this guy. Hang on. This one is this guy right here. Okay, that makes me feel better. I was trying to figure out why that was happening. Okay, the point 3, -1 has a slope of 3. Okay, the point 3, -1 has a slope of -3. The point 3, 2 has a slope of -3/2. And the point 3, -1 has a slope of -1. That's better. Okay, this point right here that I screwed up the first time at 2, -3, well, that's this point. It has a slope of 2/3. So it's up 2 over 3. That's better. So it looks more like that. I was going to say, they should be flattening out. Okay, the point here, we already did. The point here at 2, -1 has a slope of 2. So up 2. Okay, so they look like they're kind of curving around to me. It's kind of creating this circle. The point at 2, 1 has a slope of -2. The point at 2, 2 has a slope of -1. And the point at 2, 3 has a slope of -2/3. Yeah, so they're starting to kind of circle around. Okay, let's do the ones. All right, so at 1, we got that one. So at 1, 1, well, we're starting from the bottom. So 1, -3, up 1 over 3. So it looks like that. 1, -2 is up 3 over 2. It's going like that. This guy is 3, 1. That's -2. This guy is -1/2. And this guy, 1, 3, is -1/3. And then they flatten. Okay? Well, it looks to me like this side's going to do the same thing, just the opposite. So here we go. So let's just kind of sketch these in the way they look like they're going. Because we said it mirrored, right? So I'm going to just mirror these with those over there. Just kind of copying them over. So this guy looks like this. This guy looks like that. This one should look like this one, but the opposite. This one should look like this one, but the opposite. And this one should look like this one. So we've got like this circular thing going on here, which is kind of cool. So it looks cool. It's a cool looking slope field. So here we go. So we need the specific solution at 1, 1. Well, at 1, 1, we're here. So it looks like it comes in this way, but it's not going to go through because we've got this vertical asymptote, so it's probably not going to go through. And then this guy comes around and probably does about the same thing right there. So it looks like it's kind of like a circle, right? So it kind of fades its way in, something like that. That's A, okay? -2, 0 is this guy, okay? So -2, 0 is going to have a slope field that looks like, let's do the bottom curve this time. Doesn't really matter which one you do because remember it's just a generic what the function could look like. So this would be B. So this one's A, this one's B. So it should look something like that when you do your slope field.